Hello and welcome to our MEC 3503 Future of Manufacturing Group presentation. Today's presentation agenda will consist of an introduction of the vehicle multi-component, then go into each group member's individually researched components, manufacturing processes, and vision for 2042, and finally, our final thoughts and conclusion. To begin, the multi-component that we chose was a 2004 Lexus ES330, which incidentally is actually the car that I drive, and you can see a photo of it in the bottom right in the middle of nowhere. The components that we're going to be talking about are the mirrors, alloy wheels, engine block, braking system, and the chassis. For the mirror component, the Lexus ES330, like most cars, contains 3 mirrors, the 2 side mirrors and a rear view mirror. Mirrors generally contain a few materials such as glass and some sort of film, commonly aluminum. The process of manufacturing mirrors includes preparing the glass, applying the reflective metal, reinforcing with a protective coating, and lastly, quality control and inspection. All of the mirrors are manufactured in either a flat or convex manner, which provides the driver a larger field of vision for spatial awareness. Now we're going to discuss the future of mirrors, specifically in the year 2042. Something we've already begun to see are smart mirrors that can detect nearby cars and hazards and notify the driver. What we might see in the future is an increased capability and increased safety features. AI can also be used to enhance the mirrors to meet the needs of the driver for particular driving conditions, and the manufacturing processes can also be changed with AI to make them more efficient. In terms of the protective coatings that are applied to the mirrors, cold spray technology can be used, and this will help to enhance wear resistance and longevity. Now we're going to move on to the alloy wheels.
Hi, I'm Shaurya Anand, and my component is alloy wheels of the Lexus ES330. The alloy wheels provides enhanced vehicle handling and fuel efficiency, and it has superior corrosion resistance, and it has improved thermal conductivity as well for brake heat dissipation. It is designed to be flexible and to be appealing aesthetically, and the material used is lightweight aluminum alloys. For the current manufacturing, it's manufactured using casting, forging, and then it is machined and finished. And then there is quality assurance. So for casting, low pressure and gravity casting methods are used by melting alloys and pouring it into molds. Forging aluminum shaped is shaped under high pressure, which produces a lightweight and strong wheel. CNC machining is used for precision, and polishing, painting, powder coating is done for durability. Quality assurance is usually done by X-ray inspections, dimensional accuracy tests, and fatigue and integrity assessments. For the manufacturing in 2042 could be done by using 3D printing technology, which enables intricate aerodynamic wheel design with minimal waste and maximum flexibility. And for fully automated productions could be used like robots can ensure precise, consistent wheel manufacturing, boosting productivity and reliability. There could be AI-driven optimization. Machine learning can refine wheel geometry for optimal performance, durability, and weight reduction. And then there could be zero emission processes as well. We could use renewable energy, which would power manufacturing plants and which will minimize the environmental impact as well. So the vision for 2042 would look like something by using materials like advanced composite alloys. Aluminum and carbon fiber hybrids are reduced for reduced weight and increased strength. We could use intelligent self-healing coatings like nanotechnology to repair small cracks and dents, and it could be also used for corrosion prevention. Smart adaptive systems, like we can use sensors for dynamic tire pressure and stiffness adjustment for a better and comfortable drive. I would hand it off to Suliman to discuss about the engine block.
The engine block is the foundation of the engine, holding key parts like cylinders and pistons. The 2004 Lexus ES330 uses an aluminum alloy block, making it lighter and more efficient. The engine block is made using high-pressure die casting, shaping molten aluminum quickly and precisely. Heat treatment strengthens it, while CNC machining ensures a perfect fit. Nickel coatings reduce wear, and X-ray scans check for defects before assembly. By 2042, most cars will be electric, but some may use hydrogen or synthetic fuels. Future engine blocks will be stronger and lighter, using graphene-infused aluminum or self-repairing metals for durability. Manufacturing will be eco-friendly, using recycled materials in carbon-neutral factories. Instead of casting, 3D printing will shape engine blocks with less waste and more precision. AI-driven factories will oversee production, ensuring flawless quality. Cold spray technology may replace coatings, and blockchain tracking will improve transparency. Future manufacturing will be faster, cleaner, and smarter. And next up is Braking System by Donghyun.
And I'll be talking about the brake system that is a critical safety feature in any vehicle. While it consists of many parts, I'll be touching on 4 key components: the brake caliper, rotor, pass, and the master cylinder, all of which work together to safely slow down and stop the vehicle. Currently, the brake rotors are made from cast iron using sand casting. This method is cost-effective, can handle high heat, and allows for the complex disc shape. Brake calipers are produced from aluminum using die casting. This provides good strength, low weight, and efficient mass production. Brake pads are made through compression molding, where heat and pressure are applied to bond friction material with resin, giving consistent braking performance. The master cylinder is typically made from aluminum or steel through die or gravity casting, then machined to tight tolerances. This precision is critical to maintain hydraulic pressure in the brake lines. By 2042, we expect to see carbon ceramic rotors for improved durability and heat resistance, 3D printed calipers for material efficiency and custom design, and eco-friendly brake pads using sustainable fibers. The master cylinder may be replaced entirely by a brake-by-wire system, laminating hydraulic fluids and improving precision and control through electronics. These changes would make brake systems lighter, more efficient, and easier to manufacture sustainably.
Now for the Lexus ES330 chassis, it features a monocoque design, which is most popular in passenger vehicles and is great for handling and stability. It has a sedan body type, which includes 4 doors and a separate trunk space. Most likely a high-strength steel frame was used for the chassis due to the popularity of this material, and the chassis can fit 5 seats for passengers. But what does the current manufacturing of chassis look like? Well, for metal casting, there's high-pressure die casting and sheet metal fabrication. For metal forming, there's sheet metal forming, CNC machining. For the finish of the chassis, there's anodizing, galvanizing, and polishing. And for quality assurance, there's virtual testing with FEA analysis and physical testing with an example of corrosion tests. Now, what does the future of the chassis look like? Well, carbon fiber and other composites will most likely be used more in the manufacturing. For 3D printing will most likely be used more as well for creating parts. Reusable materials could be used more to reduce carbon footprint in cars. And lightweight designs will be created to optimize the weight of the cars. But what does the future of manufacturing look like for chassis? Well, as stated before, 3D printing may become more prevalent in part making. Mega casting could be used more. So instead of making smaller parts with high pressure die casting, instead would create one large part with mega casting. And as stated before, carbon fiber may become a more prevalent material, and maybe even a better composite could be made in the future. In conclusion, the future of car manufacturing seems very exciting, as with advancements such as 3D printing and better composites comes a more promising future for the automotive industry. Thank you for listening.